Hi, my name is Manuel and welcome to the video. What we see here is a robot ready to start an on-site fabrication of a steel reinforced concrete wall directly on the construction site. A 12-meter long steel wire mesh consisting of 22,000 welding nodes is autonomously built using a novel digital building process. And the only step missing is to fill the wire mesh with concrete to end up with a full-scale, load-bearing and doubly-curved wall that is part of a cutting-edge and innovative new living unit. Our paper is focused on the two complementary vision-based sensing systems that provide the necessary feedback to accurately build this wire mesh. The first system observes rigidly mounted fiducial markers placed along the base foundation of the wall to estimate the global pose of the robot. After a one-time calibration step, measurements of the marker position in images over the course of construction can be used to estimate the pose of the weld end effector in a globally consistent reference frame. We show the used nonlinear least squares optimization problems of these routines, and we also demonstrate how to maximize the accuracy of this system. The second system provides feedback of the accuracy of the build structure over the course of construction. This is required because, due to internal forces, the mesh tends to deflect away after the end effector is released from the mesh. To solve this, we use a wide baseline stereo camera pair located on both sides of the robotic end effector to identify the as-built position of welding nodes. First, we detect possible welding node candidates as lines. Secondly, we project all possible combination of lines to 3D and find the welding node that is closest to our CAD model of the mesh using a cost function. We then use this information to adapt our building plan on the fly to compensate for the measured deflection as it is built. To validate the fabrication accuracy of the wall, we performed ground truth measurement of the finished steel mesh. Red are errors greater than 2 cm. Green are errors below 1 cm. The average error is around 9.5 mm and 98% of the total geometry is within 2 cm of the design position. To the best of our knowledge, this is the largest structure which has been built by a mobile robot using solely vision-based sensing. Are you interested? We are very much looking forward to see you soon.